Hi students, let's look at this question which is on sequence and series. Let's see how can we do this proficiently. So given that the nth term of a series sequence is given by this. Okay. So find this series in terms of n and x. Okay, great. I think the main thing is to understand that this is exponential function. So essentially what we need to understand is that this will be a GP, right? So just write it down. So n equals to 1 un. This will be n summation of n equals to 1 e n x minus e m plus 1x. Okay, so this case here, what we'll get is we could distribute it in. So these are two separate GPs, right? This is the first G, second one. So just expand this in. Okay, so that will give us n equals to 1 e n x minus of n equals to 1 e n plus 1x. So we just expand everything out. Okay, once we expand everything out, should be quite okay. So this case would be e1x plus e2x plus e3x all the way to the last term, which is e capital Nx. Okay, then similarly for this guy is e2x plus e3x all the way to the last one, which is e m plus 1x. Okay, so that's about it. Every time you go over, this is multiplied by r multiplied by r. Okay, the r here is e, right? Every time you ex, sorry, ex. So you multiply ex, then you just keep similar. This one multiply ex, right? The r is also ex. So you can just use a GP formula. It's a GP, right? First term is ex. This first term is e2x. So I'm gonna just write down the formula for GP. Remember, it's a sum of n terms is a rn minus 1, r minus 1. So in this case, the a for the first GP will be ex. So ex to the power n minus 1 ex minus 1 minus of e2x ex to the power n. Okay, same thing, en minus 1 over ex minus 1. Okay, we could combine them in a single fraction. So here would then be ex enx minus of 1 minus of e2x enx minus of 1 over ex minus 1. Okay, so we can expand everything in. I don't think we need to simplify because it's not stated. Do we need to simplify? No, they just say in terms of n and x. So just maybe expand this will be e and x plus x. Okay, then minus ex minus of e 2x plus nx plus e2x. Okay, maybe we can factorize this by grouping. I think I'm not gonna add them up. I'm just gonna multiply them. Ex. Then this will be ex, enx. Right. So then I can see that I could just factorize this enx out. That's ex minus e2x, which is good. Then this is ex plus e2x. So I could factorize this out right later. The denominator is ex minus 1. Great. So then this case I could just factorize this out. Then I could factorize this out. So it's about factorization. Okay, so this will be ex minus e2x enx minus 1 over ex minus 1. Okay. Similarly, this guy, we could factorize the ex out. So ex be 1 minus ex enx minus 1. The reason why we factorize this out is because we could cancel this out. Then we'll get is ex 1 minus enx. So this is how you simplify it if you're told to simplify it. But I think you can leave it as this is fine as well, but I just simplified it. So this could be the answer. Let's look at the last part. Hence, find determine the set of value for x, value of x for which this converge. Okay, give the sum to infinity for the case where this exists. Okay, great. So from here, what we need is for sum to infinity exists. Okay, we need as n goes to infinity, or rather the capital N goes to infinity. Okay, because x is a constant, right? X is a constant. Yeah. As goes to infinity, we need e nx goes to 0. Okay. So for ex and nx goes to 0, we know that in order for this to be going to 0, this guy has to be negative. So this will tell you that nx, because e to the power of minus 1 million, negative 1 million will actually go to 0. But if it's a positive, then it's not. So basically this has to be a negative value. So nx has to be less than 0. So n is a positive integer. N is a positive integer. So since n is positive integer, okay, positive, okay, because running number. So hence this will imply that x is less than 0. If this multiplied by this gives you a negative number and n is positive, so x has to be negative. So this is the set of value of x. Okay, they want it in the set form, set of value. So state the sum to infinity. So hence sum to infinity will be this guy will go to 0. So it's ex 1 minus 0. Just ex. Okay. So that's how I do this question here professionally. If you have any questions at all, please do let us know, and I'll see you in the next question.